The preceding technology of building UI applications was Windows Forms. In short, Windows Forms is an old technology which doesn't meet current needs of users. Its rendering system is based on GDI, stands for Graphics Device Interface, and its successor, GDI+. GDI was introduced in 1985, and unfortunately it lacks the support of hardware acceleration and it's hard to use for hardware animation. Windows Forms, as distinct from WPF, unable to harness the power of modern graphics cards. And this is not a full list of Windows Forms flaws in comparison to WPF. Rather than Windows Forms, WPF is based on DirectX, so it can use all the new features of graphics cards as long as DirectX is moving forward. WPF is the solution for the whole stack of problems related to building rich UI with animations, 2D, 3D graphics, and complex compositions. Let's consider WPF benefits. One technology for everything. WPF is an integrated technology for UI applications building, no matter what you need to create. Complex UI elements, composition, complex animation, or 3D graphics, you can rely on WPF. Resolution independence. The problem of Windows Forms, though in some cases it can be also a benefit, is that it is based on raster graphics. GDI draws raster graphics images. On the contrary, WPF extensively uses vector graphics. The advantage of vector graphics over raster graphics comprised in the fact that vector-based images can be resized freely without any loss of image quality. That's why WPF apps look well on screens of any size. Separation of programming and designing concerns. WPF allows designers and programmers to do their own job. Designers to design, programmers to program. Although, still very often programmers by their own bring into life designers' models. Despite of that, this process became much less painful with introducing WPF. Infinite possibilities of customization. Very soon you'll get acquainted with the concept of lookless controls, the approach to custom controls development in WPF based on templates and gives you almost unlimited abilities for controls customization. Simplicity of styling. WPF makes controls styling trivial, much more powerful and simpler than with CSS in web design. Styles empowered by WPF resource system allow you to create skins for your applications like by the wave of a magic wand. It's impossible to list all the advantages WPF is empowered by, so we will stop at this point. Let's look at the components from which WPF is comprised of and built upon. Let's look at the high-level view of the WPF architecture. At the kernel level resides a video driver provided by a vendor of a graphic card. WPF stands on the shoulder of the giant, DirectX. Everything WPF renders is rendered through DirectX using 3D pipeline, and even 2D graphics is rendered via 3D pipeline. DirectX is the part which interoperates with the video driver, and all the nitty-gritty of rendering is comprised inside of it. DirectX by itself is a hard technology to use directly with intention to build standard UI interfaces. That's why you see this diagram with many layers. This is because DirectX has to be abstracted away. Next, you can see MIL component on top of DirectX. MIL is also called Composition Engine. MIL stands for Media Integration Layer, and this is the next layer of abstraction which provides the ability to render complex shapes in a single shot. MIL is implemented in unmanaged code, because the main purpose of this layer is to reduce the cost of interoperation between managed and unmanaged worlds. So this layer should be able to speak to DirectX, well, directly, avoiding excessive marshalling of data. In case of absence of such a middle layer, WPF would cross the managed code too often, thus incurring the performance characteristics deterioration. Presentation core is built upon the middle layer. The WPF's core layer is a low level of WPF framework and it's implemented in managed code. WPF developers rarely use this layer directly because this is mostly the next level of abstraction, which in its turn interoperates with MIL, though it has a public API which can be quite helpful in certain scenarios. The most useful features of WPF reside in presentation framework.dll. Control, styling, data bindings, all these features sit in this library. Window-based.dll provides the most basic types of high level, such as the dependency object and the dispatcher. We are going to discuss these very important types later in this course. Of course, most of the time in this course we will speak about features of the presentation framework layer. In the next lecture, you will know about what's going on in the world of .NET Platform, WPF, and their interrelationships. For some time, we haven't heard any news from the WPF team, and the WPF community almost started to think that WPF is dead, or at the verge of kicking the bucket. Good news has come on 20th of March in 2015. The WPF team shared their plans on improving WPF. One of the most intriguing features the team has been working on was WPF Local. What it means is that WPF can be deployed separately from the whole .NET framework. This will allow to update the WPF in a faster cadence as compared to the situation when WPF updates only along with the .NET framework. Unfortunately, on the 29th of October 2015, WPF team announced that they faced with hard challenges, so the WPF local project will be suspended at least for a while, as it seems to be. And nowadays they concentrate on improving system-wide WPF. They are working hard on performance issues, DirectX integration, support of new hardware, and bug fixes and tooling based on customers' feedback. All that means that WPF definitely has a future. Here I have defined several buttons. An ordinary one repeat button, one toggle button, and toggle buttons inheritors, checkbox, and a couple of radio buttons. The main purpose of a button is to be able to be clicked. I've already attached click event handlers for all buttons. Let's look inside those handlers. Each handler just prints the line which says about which button was clicked. Here and the toggle button. Okay, let's run the application and look at the output window. I click once on the ordinary button, and while I'm holding the left mouse button, we don't see anything in the output window. This is because the click event of an ordinary button fires up after releasing the mouse button. I release the left mouse button and we see in the output window that the event was fired. Here we see that. Yeah. Repeat button works differently. I click it, and while I'm holding the left mouse button, we see that the click event occurs repeatedly until I release the left mouse button. I have released the left mouse button and you see that repeat button has stopped generating click events. We see that many events have been fired. Toggle button is rarely used by itself. Mostly, toggle button acts as a base class for other controls such as checkbox and radio button. Clicking on toggle button works as with the regular button. Click event fires immediately after the mouse button is released. Yeah, we see here. But you can see that toggle button after releasing the mouse button stays pushed or clicked if you want. You see that the background of this button is not gray. Toggle button provides isChecked property, which is of nullable boolean type. And what is very important is that it provides is3state property. If this property is set to true, then isChecked property can be set to one of three values: true, false, and null, and the default value will be false. If is3state set to false, then isChecked can be set to true or false, and by default it also will be set to false. Now this button's isChecked property is set to true, because we see that this button stays pushed or clicked. If I click it once again, isChecked property turns false. And you see that button is released. This behavior makes perfect sense for its inheritors, which by their appearance mean that they can be checked, or in other words, selected. Okay, let's stop the running application. Let's take a step back and consider an important concept. What I want to address concerns all content controls we will ever see in WPF. I'm talking about the content model. And I want to show what content model is by using button's content property. As you see, I've initialized the content property of an ordinary button by the string ordinary button. But actually, content controls, button is a content control of course, has a content property of type object that contains a single item. Because of that, content controls can have only one direct child, and this child can be arbitrarily complex. For example, I can insert a stack panel with an ellipse and a text block. Let's do it. Let's expand button, and I'll just copy and paste it. As you see now, the content of this button contains a stack panel with an ellipse and a text block. When an element is a content control, all content inserted between opening and closing tags is implicitly assigned to the content property. So what we've done here with the stack panel is the absolute equivalent for the explicit setting of content. Let's expand the content property in XAML explicitly. Button.content and close it right here. As you see, the content can contain an arbitrarily complex objects, and here we set the content explicitly. Okay, let's move further. Checkbox and radio button are pretty simple controls. They derive from the toggle button class, so they expose isChecked and is3state properties. When you select either a checkbox or a radio button, its isChecked property turns true. Unselecting or unchecking makes it false. Checked and unchecked events are separated. For tracking the third state, called indeterminate, there's a separate event named correspondingly, indeterminate, and this event's signature is identical to the signature of checked and unchecked events. Despite of that, I've attached a separate handler for this event. You can see it here. I've attached the same handler for checked and unchecked events, and the separate one for the indeterminate. Radio button is another example of the toggle button inheritor. Radio button's feature is the mutual exclusion. There is only one button can be checked at the same moment. Usually, radio buttons are grouped by a container, such as a stack panel. Radio buttons which share the same logical parent, in this case, you can see this is a stack panel, become a group with the mutual exclusion among them. Before we run the application, I want also to mention that checkbox's is3state property is set to true. Here it is. What means that this checkbox can be in three different states. Our radio button 1 sets is3state explicitly to false. What is the same as not to set it at all, because false is a default value for this property. Both checkbox and radio buttons handle checked and unchecked events. Checkbox, in addition, as I've already mentioned, handles the indeterminate event. Let's look at the implementation of these handlers. Checked, unchecked, and indeterminate event handlers have a very similar implementation. I explicitly cast the sender to the base class of radio button and checkbox to the toggle button class, and then I write a line which says which control state was changed and what is the current value of this checked property. Let's run the application and look at the output window. I run the application, and now we see the output window. I click the checkbox, and we see in the output window that isCheck turned true. I click it again, and now it's null. It is in the indeterminate state. I click it once again, and now it's false. Yeah, we see this in the output window. Let's examine the radio buttons. If I click the first one, you see that now it's checked and the output window acknowledges this fact. I check the second one, and what you can see now is that the first one was unchecked, and only after that the second one was checked. Great, we've taken a look at buttons. Let's get acquainted with header content controls. I have defined here two sliders, the first one and the second one. Let's look at their properties more closely. The first one defines tick placement. This property has four possible values: top left, bottom right, both, and none. The first part of these value names defines the placement of ticks in case of horizontal orientation of a control. The second for vertical orientation. Thus, top left means that ticks will be placed on top of a control in case of horizontal orientation, and on the left side in case of vertical. Both means that ticks will be placed on both sides of a control, and none means that ticks will not be displayed at all. Our first slider sets this property to both. And you see on the designer surface that ticks are placed at both sides of a slider. The second sets this property to top left, and because its orientation is set to vertical, ticks are placed at the left side of a slider. The second property our first slider sets, named as isSnapToTick-enabled. By default, this property is set to false, and if it's false, like in our second slider, then dragging the thumb leads to changing the current value in floating point numbers. You'll see that in a moment. Tick frequency defines the number of ticks. If maximum is set to 100 and tick frequency is set to 10, then you'll see 10 ticks around a slider. Then our two sliders define small change and large change. Let's run the application and examine how all these things work in action. When I drag the thumb of the first slider, you see that the slider value changes by the value of tick frequency. If I press the left arrow, it gets decreased by 20, and if I press right arrow, it gets increased by 20. If I click on the right side of the thumb, the value gets increased by 50, and if I click on the left side, it gets decreased by 50. The second one works the same way, but with different tick frequency and small and large changes. The main difference between them is that when I drag the thumb of the second slider, you can see that the current value takes floating point numbers. This is because of the isSnapToTick-enabled property. In this case, it's set to false. Now let's look at a progress bar. At first, it's better to recall what core types are provided by the WPF framework. UI element is the base class for every element which is able to be displayed. From the layout perspective, UI element exposes two methods: measure and arrange. Soon we will see that the layout process is actually comprised of two steps: measure and arrange. The second important type is the framework element. This class exposes the API of sizing and positioning. It exposes the following properties: height, width, horizontal alignment, and vertical alignment. The third important type is the panel class. This is the base class for all panels in WPF. A panel has a collection of UI elements and composes them together. WPF provides a bunch of panels out of the box. We will take a look at them a little bit later in this module. For now, let's figure out how the layout process works in WPF. In this lecture, we are going to look at the following properties which control the sizes of elements: height, width, mean height, mean width, max height, max width, margin, padding, and visibility. Width, height, their mean and max relatives are exposed by the framework element class. These properties are of double type. If an element doesn't have height or width explicitly set, then their default value will be double, not a number. In order to get their real height and width, you may want to check actual width and actual height properties, which are going to be set right after the arrangement step. Margin property is also defined by the framework element. Margin's type is a special type thickness, which internally stores 4 values of type double. This property specifies how much space should be between the outer borders of the element itself and its neighbors. Padding property is exposed by the control class. It's also of type thickness. Padding is the same concept as margin. The only difference is that padding defines the space between borders of the element and its inner content. The visibility type is exposed by the UI element class, and it means that all UI elements can be visible, collapsed, and hidden. These 3 values can be assigned to this property. The visible value does not require any explanation. But what is the difference between collapsed and hidden values? At the measurement step, collapsed elements will set its desired size to 0. Thus, such elements don't occupy any space and stay invisible. They don't take part in a layout process. On the contrary, hidden elements retain their original size. They participate in the layout process, though they're invisible too. Let's look how all these properties work in practice. I've created here a simple window which consists of a border, stack panel, and rectangle. Let's have a look at the code behind. In the code behind, I've attached handlers for mouse down and mouse enter events on the window, border, stack panel, and rectangle. In the handlers, I just log some information about the occurred events. Let's look at how events work in the runtime. When I move the mouse pointer, you can see that firstly mouse enter fires up on the window, then on the border, then on the stack panel, and finally on the rectangle. If I move my mouse back, they won't fire up until I leave the window. Then I can move inside my mouse again, and you can see in the output window that events are getting fired. Let's click on the rectangle. As you can see, the mouse down event is bubbled. It starts from the rectangle and bubbles until it reaches the window level. There's a little trick I want to mention. Events like mouse down or mouse enter are not raised on the elements which don't have the background. In other words, if their background is set to null. Let's remove the background from the stack panel and the border and run the application. I'm slowly moving my mouse, and what we see is that firstly mouse enter fires at a window level, then at a border level, and then surprise, we don't see the mouse enter event on a stack panel until our mouse hovers the rectangle. When it hovers the rectangle, we see that both on the stack panel and the rectangle mouse enter events fire up. What's going on here? The thing is that our border and stack panel now doesn't have a background. So when the mouse pointer crosses the red border line and stays between the rectangle and the red border line, it actually hovers the window element. If we make a click here between the border line and the rectangle, we actually see that mouse down fires up at the window level. In order to fix this odd behavior, you need to instantiate either borders background or stack panels background, or both borders and stack panels backgrounds. If you want to instantiate a background of a UI element and make it transparent, then you can actually set the background of that element to the special value named transparent. Let's set the borders background to transparent and get back the original value of the stack panels background. Let's check how it works. When I click between the red border line and the blue stack panel, you can see that mouse down event bubbles and it starts from the border element. When we hover the blue background, the mouse enter event immediately fires up on the stack panel element. Okay, we've been talking about how direct and bubbling events work. Let's look at three important properties of routed event arguments. I'm talking about the handled, source and original source properties. By using the source property, we can determine the UI element of the logical tree which fired up the event. By using the original source property, we can determine the UI element of the visual tree which fired up the event. For example, it can be a text block of a button. We can stop the propagation of an event by setting the handled property to true. Let's try these properties in practice. I want to stop the propagation of the mouse down event on the stack panel. Besides, I want to change the background of the event source UI element. I've prepared a short code snippet. Let's look at it. I just log the original source and source properties here. Then I try to cast the source UI element object to a rectangle and change its background color. Then I check the event sender if it is a stack panel. If it is, then I mark the event as handled and bubbling stops. Let's run the application. I move my mouse to the rectangle and click on it. And as you can see in the output window, the event bubbles until it reaches the stack panel. It doesn't bubble up to the border and the window. Okay, I hope we've figured out how all these things work. Let's take a brief look at tunneling events. I'll just uncomment the corresponding code and I'll comment out attaching to mouse down and mouse enter events. Let's run the application. I'll click on the rectangle, and as you can see in the output window, the tunneling event starts from the root element and tunnels until it reaches the rectangle. Okay, let's recap what we have learned in this module. Date binding mechanism comprised in the class named binding. It can be used in C# code, but almost always you will use it in XAML as a markup extension. The most useful properties of this type are source, which defines a source object, path, which defines a path to a source property, which belongs to the object referenced in the source binding property. For example, source property can point on an instance of type student, and path can point to its, say, name property. Element name. Element name has the same meaning as the source property. The only difference is that element name is used for referring to named UI elements defined in XAML. Mode. It defines a binding mode, which could be one of the following: one-way, two-way, one-way to source, and default. Default option is a little bit slick. If you apply binding to a certain UI element with this mode, that binding will use the mode which is defined by that UI element as a default mode. For example, text box defines two-way mode as its default binding mode. Text block defines one-way mode as a default. It's much better to never rely on a default mode, always define binding mode explicitly. One-way mode is a mode when updates go only in one direction, from the source to the target, e.g. from the source property address of a person class to the target text property of a text block. Two-way mode is a mode when updates go in both directions, from the source to the target and vice versa. One-way to source mode is the same mode as one-way, but the other way around. Updates go from the target to the source. We will address some additional valuable features along the next practical lecture. Let's have a look at a basic data binding scenario. We have a solid color brush defined in window resources here. In the stack panel we have two rectangles. The first one defines its fill property using static resource extension, referencing the brush defined in window resources. The second one does the same, but uses dynamic resource extension. Next we have a button named Change Color. Let's look at the click event handler implementation. What's going on here is that our event handler just changes the color of the brush to green in the runtime. Let's run the application and look what will happen. I'll click the button, and what we see is that only the second rectangle, which uses dynamic resource extension, changes its color. Now you see the difference between static and dynamic resource extensions in practice. In the next lecture, we will reveal the algorithm of resources lookup. Let's look at what Visual Studio generates from a standard WPF application template. We've seen the Solution Explorer two XAML files and their corresponding XAML.cs files. We have already seen main window.xaml and XAML.cs files previously in this course. We've seen how main window declares that it is connected with its C# source file. The same thing goes with app.xaml. Let's have a look. You see here that it declares an application class instance. But where is the main method of a program? If you look at properties of app.xaml, then you'll see the following. It is marked as application definition. What it means is that app.xaml becomes a special case. Visual Studio generates the main method, which is hidden inside the generated class. You can look at it this way. And here's the main method. Don't ever touch anything in these generated files. In the best case, Visual Studio will anyway rewrite all your changes. In the worst case, you can freak out Visual Studio. You definitely don't want to do this. We're not going to discuss how to create your own main method in a WPF application. It's possible and it's simple, but it's a rare case when you really need it, so this goes beyond of this course. Instead, I want to mention that without direct access to the main method, you don't have also direct access to the command line arguments, which can be passed into the main method. But actually you can grab them, and you don't need to have a direct access to the main method for this. Let's go to app.xaml.cs and look how you can grab CMD arguments. All you need is either to call environment get command line args at any point in your application, or override on startup method in the app class and just take arguments from the event arguments. Great! Now let's look at the application class more closely. I guess that one of the most popular questions that newcomers ask on StackOverflow.com is why I get the invalid operation exception, which says in its details that the calling thread cannot access this object because a different thread owns it. Let's answer why. In 99% of cases, WPF application spawns the only one dedicated thread for managing UI. Let's reveal what it actually means. When user somehow interacts with the application's window, operation system sends a message to the application. In order to handle the user's actions, application should listen to that messages. This duty is appointed to the dispatcher class in WPF. When WPF application starts, the main thread becomes associated with an instance of a dispatcher. Dispatcher starts a loop where it listens to those operation system messages and dispatches them properly. Let's recall how WPF classes hierarchy looks like. As you remember, all WPF infrastructure-related objects inherit from the dispatcher object. Dispatcher object class has a dispatcher property of the, dispatcher type. It means that every UI-related object associates with the dispatcher and as a consequence with the thread in which the dispatcher lives. The threading model of any WPF application restricts access to instances of dispatcher objects from threads that don't own that object. It means that the UI thread allocates UI-related objects. It owns them, and only that thread has rights to access them. Dispatcher has a strategy of verifying calls to objects associated with the dispatcher. If the dispatcher's thread ID equals, say, 1, and a chunk of code tries to modify the object, say a button, which is associated with that dispatcher, from the thread with ID 100, then dispatcher will throw the corresponding exception. Let's see how WPF threading model works in practice.